A 2 kilo block is dragged along a frictionless surface using a massless cable. And a tensile force on the cable has a magnitude of 2 newtons. And we're asked to draw a free body diagram showing the forces acting on the block. So what we have is the force of weight acting through the center of mass, pulling that block downwards. And we have a normal force, which is a contact force that's preventing this block from sinking into the ground. And a tension force on the massless cable is transmitted to the block. So there's only motion in the horizontal direction, and the acceleration is in a direction of the net force. So applying Newton's second law in the horizontal direction, we have the tension force is equal to the mass of the block by the acceleration of the block. So that's equal to 2 newtons. The mass is 2 kilos. So the acceleration of the block is 1 meter per second squared. A person weighs 80 kilograms and steps on a scale placed on the floor of an elevator. And we're asked to find the reading on the scale in newtons if the elevator is accelerating upwards at 4.2 meters per second squared. So if the elevator is accelerating upwards, there's going to be a contact force from the scale on the person, which is the normal force, and a force of weight pulling that person down due to gravity. So given that the elevator is accelerating upwards in part A, then the normal force is larger than the force of weight. And if we choose our upward direction as positive, well, we have the normal force minus the force of weight is equal to the mass of the person times the acceleration of the person. And the force of weight is mass by gravitational acceleration. And putting that on the other side of the equation, we have the normal force is mass by the acceleration plus gravity. So if you substitute for the mass of the person, the acceleration, and gravity is 9.8 meters per second squared, you'll see that the person is heavier when the elevator is accelerating upwards. Now repeat this process for case B and C, and post your reasoning in the comments. A box with a mass of 3 kilos is attached to a roof by 2 cables, and calculate the magnitude of the forces in both cables. So drawing a free body of the block, we have the force of weight and the tensile forces in both of those cables. So given the block is in static equilibrium, we can apply Newton's first law in the horizontal and vertical directions. So using trigonometry, we obtain the following expressions. And in the vertical direction, we obtain the following expression. Where we have the force of weight is the mass by gravitational acceleration. And we took our positive directions to the right and upwards. And now you can solve these simultaneous equations for the forces and post your answer in the comments.